So now in this video, we're going to simulate using a lithium ion battery, a single cell battery right there. So when it's fully charged, you can expect 4.2 volts. If you charge it all the way, maybe 4 volts. But in any case, with this circuit, we're using a PNP bipolar junction transistor. We're going to make it where as long as power applied, the LED is lit up. But when it drops to about 3 volts, then the LED is off. That was my goal for here. That's to help protect a single cell lithium ion battery. There's a little bit of current trickling through. This circuit will never end it completely, but it's not much. Should give you plenty of time to swap the battery or recharge it or whatnot. So I used a blue LED to set the voltage along with the PNP bipolar junction transistor. They both played a part in that. You have the base to emitter drop, in this case emitter to base drop, plus whatever the LED has. So the green LED should have the same forward voltage as the blue LED, but it looks like it's conducting a little bit earlier. Maybe it's because it's somewhat damaged or something, I don't know. But in any case, you can see we got the green one there not doing as good. So whatever extra voltage we have to add, this is a Schottky diode, it's going to add approximately 0.3 volts. So it's forward biased right now. The direction it conducts more easily. It's kind of like a rectifier diode, except for it has a lower forward voltage. That's the main thing. And it doesn't do as good of a job with rectification. But they don't do a bad job either. So if a rectifier diode drops too much, you can grab a Schottky. We'll take a closer look at that later. But there you can see 2.9 volts, and we hit the, it says 0 milliamps current. Again, there's a little bit of leakage. But in any case, you don't want to drain a lithium ion battery, a single cell one, less than 2.5 volts right there. That's the main thing. So as long as we stop the current close to 3 volts, we should be pretty good with most batteries. And here is the schematic diagram. So as I said before, using a PNP bipolar junction transistor, the arrow's pointing in, and also the emitter is on the positive side instead of heading down to the negative side, which the NPN bipolar junction transistor does, has an arrow heading that way. But in any case, we have the PNP. We're using a 2N2907. So this is an important transistor to be aware of because it's known as a complementary transistor to the 2N2222, which is an NPN bipolar junction transistor, but they can handle basically the same amount of current. That's the main thing. Their electrical properties are basically the same, except for the chemistry is opposite, so current flows at opposite ways through them. The 2N3906 can only handle about 200 milliamps of current, and we're really close to that even in this circuit. This can produce more than 200 milliamps of current. So you definitely would not want to use a 2N3906 or other transistor that can't handle. That is a PNP version of the 2N3904. They can handle about the same amount of current again. So there is a pin layout, left pin emitter, middle pin base, right pin collector. Really common pin layout if it starts with 2N and it's a bipolar junction transistor, whether it's NPN or PNP. So in any case, we can just put a voltage across the LED module here up to 5 volts. And when it's at 5 volts, it's about 1 watt of power that it dissipates. Gets up to like 250 or more milliamps of current. In this video, only about 140 it looked like, maybe 130, because some of that current was what was going from emitter to base over there. So we have the lamp there. We talked about that part of the circuit so far. There you can see up to the emitter, because flat side's to the left, base in the middle to the resistor, and collector down there. We're going to reattach. The power's off, and it's set at 3 volts, so it won't light up anyways. But in any case, we will plug that in just so you can see how I had it wired up there. Now we have to limit current right there. You can see we have a path from the positive supply emitter to base, so that's going to drop about 0.6 volts, and then the resistor, and the LED might drop about 2.5 volts at very low current. So that adds up to about 3 volts. We could go to ground. We were able to do that with the blue LED, whereas this green LED that I use doesn't appear to be dropping that much. For some reason, I don't know. Maybe a different green LED will drop more. But in any case, we just added about 0.3 volts with the Schottky diode. The Schottky diode that I used came out of the Joe Knows Electronics kit. The 1N6263 right there. So that's the kit. I really recommend that kit. once you have the basic component. And I must have held it wrong. They fell out. But in any case, you put that in series, it just drops another about 0.3 volts. And as we saw, that's what it took to basically stop current at about 2.9 volts. So doesn't ever stop it perfectly in the circuit. A little bit of current always trickles through these semiconductors, even when they're below their forward voltages, just a tiny bit though. And a little bit more will trickle through that way as well. But much less than 1 milliamp of current. So it should not drain a battery too fast. As we saw, we needed the Schottky diode with the green LED, but with the blue LED, so you could see that they were in series there, headed to ground. These are both forward biased, by the way. Schottky diodes are used forward biased, just like rectifier diodes, when you want them to conduct. Reverse bias, they stop current up to their breakdown voltage, which you never want to exceed with a Schottky diode. And they're like rectifier diodes, just they're not quite as good other than their lower forward voltage. That's the main benefit if you need that. Pop that up. So the blue one we just put directly to the negative supply. So that's really about it. The 2N2907, as I said before, is all over the internet or in books. You'll hear it's complementary to the 2N2222. It's not as common though. I just happen to have a kit that actually had one. Otherwise I would have had to buy them or use a different PNP bipolar junction transistor that can switch 600 milliamps of current. So I don't know the name of the kit that I got it from. I don't use many components from that kit. It's not really one that I recommend. But in case, you may have to search around for these, buy them individually if you want them, or find a substitute if you're going to wire a circuit like this. You could just use a higher wattage transistor as well. That's probably what I'll do in the next video or two, to light a couple of these. But you could use a higher wattage transistor to just light one too. That's no big deal. But in any case, that's it for this video. So hope you enjoyed. Make sure to check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.